Okay, since we have the value for x solved for, or have a specific value for that x in terms of y, we're going to take that value for x and we're going to substitute it in to the other equation's x. We're going to take and put this into there. So I'm substituting this value as a whole into that x. I'm going to insert it using parentheses.
Yeah.
So I'm going to have my 2, and then I'm going to replace x with this value because it's equal to x. That's negative 3y plus 11, and then minus y equals 1. What have we done to that, or what do we have now in this equation by doing that, Ethan? Well, we're going to have to use the distributive property, but what's the situation we have now? Do we have 2 unknowns now?
No, you only have
No,
one.
we only have 1, so can we solve for 1 unknown in the equation? Yes. That's why we do that. We're substituting in this value for y, or for x into there so that now we can solve for y. We'll use distributive property. 2 times negative 3 is negative 6y plus 22 minus y equals 1. And then I'm going to combine a couple steps here. Negative 6y minus 1 is negative 7y. And then subtract 22. Subtract 22 is equal to negative 21. So y equals 3. We're not done because what do we have to do, Ethan? We have to solve for x still. We've only found y. So we're going to take our value for y, and now we're going to plug it in or substitute it into here. Because if I have the value for y, I can solve for x. I know x is equal to that expression. So negative 3 times 3 plus 11, negative 9 plus 11 is 2. So your x is 2, your y is 3. We're going to write our answers as an ordered pair then. So this is going to be the ordered pair 2, 3.
Why do you write it as an ordered pair?
Good question. On, let's see if I can bring this back up. Not that one. Okay, if I were to take this, and I don't know what the actual equation or the lines look like, but when you have those two lines, there is some point at where they intersect. Okay, if I went back to that problem and I graphed them like we've been doing, this point where they intersect is that solution. That's the point that will work for both equations. So if I graphed this and I graphed this, there's some location in space where they're going to intersect, unless they're parallel. Okay, and that intersection point is 2, 3, the ordered pair 2, 3. We can plug in 2 and 3. 2 times 2 minus 3 is 4 minus 3 equal to 1. Yes, that's a true statement. Does it work here? 2 equals, we already know that 2 equals that because that's what this was. Okay, so that point gives us a true statement in both equations. Yes?
Why do you have it in ordered pair if it has A and B up there?
I was trying to remember, I wrote A and B to be able to communicate, I think. Last year I think I said take the equation from B and plug it in or something like that. Okay. I couldn't remember, when I saw it today I couldn't remember what I used it for, so I just played. No, I didn't use it at all.
Did you lose your red marker?
No. Alright. So use substitution on this one to solve for x and y again. We're given that y is equal to x minus 6 So I'm going to, on this problem, replace the y with this value, because y is equal to this, so I can replace this value of y with x minus 6. So that's 2x plus 3 times x minus 6 equals negative 13. Then distribute 2x plus 3x minus 18 equals negative 13. Combine these two like terms, 5x, and add 18 to both sides. 5x equals 5. X equals 1. What's wrong, Kelly?
I'm trying to keep up, but I can't. I don't understand.
Remember, you're going to be able to watch this later if you need to take notes later. I'd rather you kind of watch more here.
Okay.
If you need to replay it to get notes so you can see it rather than trying to write stuff down. So I distributed 3x through, or the 3 through, and got 3x, so adding those gives me the like term of 5x. I added 18 to both sides is 5, so x equals 1. Then I'm going to take the value that I found for x, being 1, excuse me, I'm going to plug that into this x, so that I can have a value then for y. So y would equal 1 minus 6, which is negative 5. So I write my answer as an ordered pair, 1, negative 5. I always put the x first in an ordered pair. Okay.
Is that as hard as I thought they would be?
They
That-
look more complicated than that.
Yeah, they look more complicated.
If you had an extra number, like, and you had the 3x plus the 2x, or, okay, the second one, no, in your work, okay, that one, if you had a like term to match the 18, would you match that up?
Yeah.
And then,
Okay, so here we're given that x is solved for us. So we're going to take the value of x, plug it into the x in the previous problem. So I'm going to have 3, and then I'm replacing 3y minus 10 into my x plus 2y equals 3. If you substitute that in for your variable and you still have different variables, if you have an x and y, once you've done that, then you know, oops, you substituted it in for the wrong variable. You catch what I'm saying? If I were to have made the mistake, okay, I have 3y minus 10, and I put it in for y here, then I'd end up with 3x plus 2 times 3y minus 10 equals negative 3. I haven't gained anything, have I? Because I still have an x and a y. And I don't want different variables there. I want the same variable. That's why we have a y and a y in those situations. Okay? Just a way to catch yourself in case you do something silly. 3 distributed through is 9y minus 30 plus 2y equals 3. Combine your like terms. 9y and 2y is 7y. I'm going to add 30. Add 30.
It's 11y.
It's 11y.
What did I do wrong? Huh?
You're gonna add your
Ah, 11y. No,
There you go.
I subtracted instead of added. See, do something silly like that. 33, y equals 3. And then we take that value, plug it into there. X equals 3 times 3 minus 10. 9 minus 10 is negative 1. So the ordered pair is negative 1, 3, and there's your answer.
Will you pop up on our recording?
Yeah, yes, it will.
That's awesome.
you should
Can
say
I send
stuff
a
on
text
it.
to her? No, I was gonna say, yo ain't a word.
Yo yo.
Say sup, homie.
That's what.
Yeah, say that.
Yo ain't a word. I just wanted to say that.
Recording.
Say sup, homie.
No, you spelled it wrong. You spelled it wrong.
Oh, how do you spell
It's
homie? Oh. So that's homie.
No, that's like honey with an M.
Yeah.
Honey?
Oh,
Hummy?
it's
So it's
already-
hummy.
I-
Hummy.
Hummy and stuff.
Say spell check it. Okay, I'm gonna listen now.
Okay.
I'll mess up on Facebook and I'll be like,
What's your, yeah.
How'd you, the 11y equals 33.
Right.
And then you got y equals 3. How did, oh, did you divide 11 and 13?
Yeah, I just skipped that step. 33 divided by 11 is 3.
Okay. So then you plug the 3 in for the, you plug the 3 in for the y.
Right, because y is now, we know y equals 3, so I could take and plug it in here. You could go and plug it into this one, and you'd be able to solve for x, but it'd just take longer.
Okay,
So I'm plugging it into the easier
so
one.
you times those?
3, because that's indicated product
So it'd be
between
Minus 10.
9 minus 10, -1.
And then,
And your ordered pair, x is -1.
do you always put the y second?
In every ordered pair you will ever write, it's always x, y.
Oh, yeah.
Okay, we have y on this problem given to us, -3x plus 8. So we have -x minus 2 minus 3x plus 8 equals 4. -x plus 6x minus 16 equals 4. Combine these two is 5x. Add 16 to both sides is 20. So x equals 4. And then we plug that value into here. Y then is -3 times 4 plus 8. -12 plus 8 equals -4. So your ordered pair, we put the x first. So it's 4, -4.
Okay.
I ran the box out from, can I have another one?
Sure.
I ran Kelly's out when I was in the office, and so I took the one from the lab. And
You do,
and
you're
you
running
went in the
back.
lab and then Kelly's, so I can't. I'm clean this hog, I can't.
I think this is might be the last one.
Oh, great. Right after I learned that, then you're just not even putting letters in it.
Putting any numbers?
Or numbers, yeah.
Doesn't matter then. Right? Just x is written first, so let's take and replace x with y. So we're going to replace this x with y. So 2y plus 3y equals 5. 5y equals 5, y equals 1. If y is equal to 1,
X equals to 1.
x has to equal 1.
oh, it's 1, 5.
Did you say hot chocolate spilled on this?
No, it was Dr. Pepper icy.
Icy.
Smells like
Oh, this is rough.
whatever I just said it was. Hot chocolate.
Is that
Okay, again, one more time for you. This point that we're finding, and the reason we're writing it as an ordered pair is because it's a point, is the point at which each of those lines, because they're linear equations, each of those is a linear equation that gives you a line, so where they will intersect. We're going to have a method of solving this. It's called the elimination method. And we'll use the elimination method later, and we'll also actually solve by graphing. Later on, when we get more comfortable with graphing, we'll actually graph the two lines and find where they intersect to find that point that's the solution to that. Yes, sir.
Are we going to learn more about slope this year or in geography? Or in geometry?
You will learn more this year, I think. We will be using it in graphing lines and stuff. Okay. All right. So your assignment, I already told you, problem set 54, 1 through 30. Due Friday. You've got, we'll get to work. Quit whining and get to work. You have 25 minutes and seminar.
What it? And I just